far today, we've actually seen a lot of core components to programming in general, and then, of course, specifically in Python. We've played around with strings, we've played around with numbers, we've played around with date types. Now it's time to start adding a little bit of logic to our code, adding in a little bit of branching, and we start off that by utilizing if statements.
Absolutely. When we start doing problem solving with code, one of the things that we're going to have to end up doing is helping our code make decisions, figure out when to do what. Otherwise, we're going to be very limited in the types of problems that we can solve. So let's say you're working at a bank. One of the rules they have at a lot of banks in North America is they'll waive the transaction fees if you maintain a balance of over $1,000. So if you're writing a program that has to calculate what fees do I charge a user, you need to be able to say, well, if it's over $1,000, don't charge this fee. If it's under $1,000, charge the fee. Very simple, but very real world. If a user has canceled an appointment less than 24 hours before an appointment time, a lot of times you still have to pay for the appointment. So again, if you were writing the program that was sending out bills, it would have to look at, well, what time did they cancel the appointment? If it was canceled a week ahead of time, don't charge them. If it was canceled within a day, charge them. And then I have to add a little Canadian reference here, right? My Twitter handle is Hockey Geek Girl. I am a Canadian, and I do love my hockey. So the other analogy I have is if a hockey player does get the puck in the net, then you add 1 to the score. If they miss the net, obviously you wouldn't do it. And you may be sitting there going, Susan, why would you ever write a program to do this? Well, hey, I could be creating a video game. There is Pygame, which helps you use Python for video game development. And you know what? If you've ever go to a hockey game, there is actually a sensor inside the net at the professional hockey games. And when the puck goes in there, the sensor detects it, and that triggers the little light to go flashing and the little whee, that lovely horn noise that always goes off when someone scores a goal.
We're not going to do sound effects on that.
Yeah, that's never good. But that's code. It's saying if the puck goes in the net, then play this sound, light this light. That's code behind the scenes what's happening. So there's tons of situations, real situations, where our code has to say, if this happens, do this. And that's what we want to get into here. So what we're going to do is we're going to use an if statement. So if we take a look at the code here, there's a few pieces of code here in terms of syntax. We start off, hopefully that first line of code looks familiar and isn't scary at all.
Yep.
Right? So I'm using an input statement to ask somebody to enter a value. I'm storing the value they give me into the variable answer. Now, so what do we do have as syntax, though, is we have an if statement. So we're saying if the answer they give us, I'll talk about this in a second, is yes, then print the following message. So without worrying too much about syntax just yet, basically we're saying if the answer is yes, print, that will be an extra $10. Because I'm saying, do you want express shipping? Yes, okay, then I'm going to charge you more.
It sounds actually relatively close to English, that essentially what you're saying is if this is what I want, then do this.
Yeah. It really is.
If this is the state, do this.
Exactly. So now we understand the logic of it. Let's go back to the slide and take a look at the syntax behind it. So you have the keyword if that indicates we're looking at a condition. You have a colon at the end of the line. That is very specific to Python syntax. If you forget that colon, you're going to get weird little error messages appearing in your screen, and eventually you'll go, oh, I forgot the colon. That's one of the ones I forget all the time. And then the other thing, and this is very significant, is the print statement is indented. That's how Python knows what's the command that I only execute if the answer is yes. If I say answer is no, and you have indented code, that code's not executed. So the indenting is crucial here because that's how Python knows what is the code you want me to run when the answer is yes. Now, if we go back again to the code, there's one last little piece I want to show you, and that is this double equal sign here. You'll see this in some other programming languages as well. In earlier code, we even have it on our previous line here, we use the equal sign to mean take this value, put it in here. So we say take the result of our input command, our input function, put it into the variable answer. So we're assigning answer the value returned by the input function. So the equal sign means take this value, put it here. So we can't use that in an if statement. It would be confusing.
Exactly, yeah. And that's really, it's sort of both for us, but it's also for the runtime as well to understand the difference between an assignment where you're taking a value, putting it into a variable, and when you are trying to do a comparison.
Right.
Yeah.
So as a result, we end up with a special syntax. When we want to say if something is equal to something else, the double equals is the syntax for saying is equal to.
Yep.
So now if you look at this slide, we're saying if answer is equal to the string yes, then we have our colon. That's just part of a syntax. Then print on the screen, that's going to be an extra $50.
Perfect.
So that's the syntax. Let's just look at a few examples so you can get a handle on it. We'll do a demo as well so you can start to get comfortable with it.
It's sort of funny watching the Q&A right now because there's now a little bit of hockey banter going back and forth. You know, go Ducks. Somebody said, you know, we should make a dyno to set off the horn every time the Rangers score. Somebody else said that'd be a very quiet dyno.
Oh,
I mean,
man.
Yeah,
And I'm sorry, speaking as a hockey geek girl, it's go Sens go. So I am a diehard Ottawa Senators fan. So, but I have any great hopes of winning the cup this year. But I am, for the record, go Sens go. So I showed you the double equal sign for is equal to. It's probably a good idea to talk about some of the other symbols you might need to use.
Yep.
Because sometimes you might want to say, is it not equal to? And that's another one where you just have to, this is one of those ones you will actually end up eventually memorizing it because you'll use these fairly frequently. Not is not equal to, the symbol for that is a exclamation mark followed by an equal. The exclamation mark is frequently used in programming languages to mean not. And that's why exclamation mark equals means is not equal to. So it's a convention that's been used in other programming languages. So the nice thing is, yeah, once you learn that syntax, you'll be able to use it elsewhere. Then if you go back to the slide, we can see a less than symbol. That's nice. It's the same as when we learned it in school.
Yep.
Greater than. One we didn't see necessarily when we're doing math in school is that less than or equal to. Because there certainly are times like, hey, wait a second, I said you don't pay service charges if you maintain a balance over $1,000.
Right.
But what if it's exactly $1,000? Do I have to pay the fees?
It's a good question.
It is. And is that a question the programmer answers?
No.
Yeah, this is one of the things you will run into in some situations. If it's your bank, you're defining the rule, and you're saying, well, no, it has to be over $1,000. So you have to have $1,000.01 to not pay transaction fees.
Right.
So this is actually something you will frequently need to double check on. And if you're writing code for someone else, you'll probably need to go ask them. Because they'll often say, oh, if it's over $100, you know, if they make a purchase over $50, shipping is free. What if it's exactly $50? How do you want to handle that? Because you may discover if it's greater than or equal to $50, the user should not be charged for shipping or doesn't pay transaction fees. And the syntax for that, as you can see here, is greater than equal to or less than equal to. And there's some examples on the right-hand side of sort of what the code might look like.
Yep.
But I will say, we talk about making mistakes as coders. One of the most common mistakes we make as coders in if statements is less than should have been less than equal to, or greater than should have been greater than equal to. That is one of those. And it's one of those ones that the code works, but it doesn't do what it's supposed to do.
Yeah. Yep.
Yeah. We getting more hockey comments in the background
No,
there?
well, we are, but yeah. I was actually laughing. I was paying attention. I was listening to it, and I was laughing at that because that really is one of the hitches in my delivery, that I frequently inverse the Boolean statements.
Yeah.
So, yeah.
Easily done.
Yep.
So here's another example of an if statement. And this is an example on the slide here. And what's significant about this is I want to point out the indenting here. So Christopher, do you want to take a guess here at if I ask somebody, would you like express shipping? And if they answer yes, I charge them an extra $10. Now, if they answer yes, do you think they're going to see that message, have a nice day?
I'm going to say yes, based on what you told me about tabs. And because of the fact that print is back on that first line, I'm going to say that yes, have a nice day is going to print.
And what if the person says, no, I don't want express shipping?
I'm going to go with the same thing because of the tab.
So all in all, so if somebody says, yes, I want express shipping, what do you think is going to appear on that screen?
Right. I think if somebody says yes, I think it's going to print out, that will be an extra $10. Have a nice day.
Right. And if they answer no?
Have a nice day.
Exactly. Because, and this is sort of where that indenting is so important to see, and I just wanted to illustrate that a little more clearly, that only if the answer is yes will the statement that's indented, or the statements, you could have multiple commands here, only then will those statements be executed. The code that you have that's not indented, doesn't matter if the if statement is true or not. Basically, it's going to ask the user for if they want express shipping. If they answer yes, it'll print the statement. But regardless of what they answer, it will continue executing the non-indented code, and everybody will see the message, have a nice day.
So if I wanted multiple lines to execute on that if, I would just need to keep tabbing them in to make sure that they're all there. Okay.
Exactly.
Perfect.
So you indent however many lines of code you need to execute. If answer is yes, you just make sure they're all indented. When you have a line of code that's not indented, it says, oh, that was all the code you wanted executed in that if statement. We're good. Now I just execute this code all the time.
I like it.
So the print statement being indented is essential. It's part of the Python syntax. Particularly important for if statements, and later on we'll see it with loops as well. All right, so let's take a look at that in terms of code, because you actually brought up an interesting scenario there, Christopher, of like, what if I do want things like multiple lines of code executed? So let's try that out. Whoops, cancel. Sorry, didn't mean to do that. All right, so let's go write some code. And what I'm going to do is I am going to say, let's see, favorite team, based on the conversations earlier, input, what is your favorite? And you know what? I'm gonna stir it up a little by adding a U to the word favorite, just for the Americans out there. All us British, Canadian spelling folks, Canadians are famous for inserting extra U's and everything. We even pronounce the word about as if it has an extra U. So I'm going to include that there. What is your favorite hockey team? And then I'm going to say if favorite team equals Senators, then I put my colon. And now one of the nice things is Visual Studio is smart enough that when you hit the Enter key after the colon, it automatically indents the next line. Because it's guessing you just wrote an if statement, chances are you want to now write the code, but only executes if the if statement is true.
Yep.
And if favorite team equals Senators. Oh, and I've already got a typo.
Yep.
Before everybody starts throwing it into the comment window going, Susan, you've got a mistake, that should be equal, equal. So if favorite team is equal to Senators, and that requires the double equal.
Somebody else has already written one out for Blackhawks, by the way.
Awesome, very nice. Then I'm going to say, yeah, go Sens go. Go. And then I'm just going to say print. It's okay if you prefer football/soccer, because depending on the country, you may call it football, you may call it soccer or cricket or tennis or insert sport here.
Now, real quick, just to answer the question in the chat window, if we bring the code back up, right there you've got if favorite team. By the way, you've got okay, you've got a small inconsistency. You said favorite on the display, but favorite on your variable name without the
okay,
but in any event, just to answer the question, that double quotes, that's checking a quality there. So single equals.
You mean the double equals?
Sorry, double equals. Double equals. The double equals is a quality. The double equals is a quality. Single is assignment.
Yes. So single means take this value, put it here. Double equal means is this equal to this?
Exactly. Yep. That's it.
You've got it. And yes, just to be consistent, I'm going to add an extra U to my variable names too, since you pointed it out.
Yep.
So if I run this code, and let's just slide it over so you can kind of follow the logic, and I enter Senators as my hockey team. Yep. Then it says, yeah, go Sens go, and it's okay if you prefer football or soccer. Whereas if you run this and you say Leafs, my son is a diehard Toronto Maple Leafs fan. It's a very tough life. They're not known as the top team in the hockey league. And I just say, well, it's okay if you prefer football or soccer, but it doesn't display the go Sens go.
Okay. Perfect.
And just because we were talking about what if you have multiple commands you want to execute, if a condition is true, I'm just going to add a second line of code here. And I'm going to say, but I miss Alfredson. We had a tough time with my team. They traded away our captain last year, so we miss our old captain, Daniel Alfredson. So anyone who would say favorite team Senators would know about Daniel Alfredson. But if you don't know the Senators, well, that's not going to mean anything to you. So I'm only going to display that message if you say you like the Senators. So now, when I specify Senators as a team, it says, yeah, go Sens go, but I miss Alfie. And then again. So you can see all the lines of code that are indented are only executed when you specify Senators as a team.
Perfect. Okay.
Now, of course, there's one thing that eventually somebody's going to be going, but what if? Yep. What if I enter Senators in lowercase letters?
Only one way to find out.
Yeah. So, because you'll notice when I said if favorite team is equal to Senators, I put an uppercase S there. What happens if I type in lowercase? So is the string, and I'm going to ask you, the string senators in lowercase letters, is that the same as a string senators with an uppercase S?
Well, first thing this morning we learned was Python is case sensitive, so I'm going to say those are different strings.
Yeah, let's find out. And, oh, look at that. It comes back right away. It does not think my favorite team is the Senators. It is case sensitive.
And there's actually one other big thing that's worth pointing out here, since now we've done it the other way, is that you'll notice on the display that it just simply says, it's okay if you prefer football, soccer. It does not say either of those two tabbed in lines. It doesn't say anything about Go Sens Go, or in particular the second line, it does not say I miss Alfie because of the fact that those were tabbed in. So you'll notice the tabs, again, make a big difference there.
Yeah, those tabs. And because they were tabbed in, those messages do not appear.
And a couple of people have mentioned, you know, the tabs there is subtle. And absolutely, it is. But one big point that I would make here is this is actually a good habit to get into anyway, because there are a lot of other languages like VB where they're going to use an end if, or C#, which is going to use curly braces to denote the beginning and end, where technically that's what's going to figure out what's going to run if that happened to be true or not true. But you're still going to want to tab it in anyway just to make it more readable. So is it subtle? Absolutely. But it's still a very good habit to have gotten into anyway. So when you make the move to another programming language or to another programming language, you're going to have learned these good lessons.
Yeah.
So yeah, it is subtle, but yeah.
But at the same time, it's interesting. If you look at the code right now visually, what jumps out at you is, hey, there's some code here that's pushed over to the side.
Yep.
And it is very visual. A nice, simple way. The Python interpreter has to have a way of knowing what code do I execute only if statement is true. Yeah, you have to have brackets or something to tell it, stop here. But the indenting, it's actually a habit most of us do in other programming languages anyway. So they just said, let's just adopt what they're doing anyway and not make you write anything extra.
Exactly.
That's the way I like to think of it. It's just less work.
Yeah, there you go.
I'm a lazy coder. I like it.
And again, just to highlight, those do need to be tabs. You need to tab in.
Which it will do by default when you hit the enter key. But if you need to add extras, yes, that'll work. So that's your basic if statement. Now, I guess we should fix that, shouldn't we? Now, I'd left us sitting here hanging with a problem. Which is somebody typed lowercase and, you know, didn't find a match. So we should really fix that. Now, if only there was a way we could use something to manipulate a string, because the problem is I have a string, and the user didn't enter it the way I expected them to. If only.
I remember doing a module on this.
On strings,
I remember
variables.
I was typing something in, like IntelliSense came up. That was cool.
So, exactly. We saw a number of functions we could use to convert values. So I could take, for example, I could take the value for favorite team, and what if I converted that to uppercase? Right? Okay, now this is a funny one, and I've done this before to myself by accident. This is one of those silly mistakes. I told you I'm good at finding coding mistakes because I've made a lot of them. And here is an exact example of a piece of code I have written and run and beat my head against a wall going, why isn't this working? So take a look at this code for a second. I'll give you a second to read it. And see if you can spot Susan's mistake. I'm going to run it now. I'll leave the code up on the side so you can still look at it and see if you can see what I did wrong. And I type in senators, and it's going to convert that for me to before it does the comparison. And then I enter senators, and it still says, hey, it's still not executing my if statement. Can you see what I did wrong? And I have done this. Go ahead, Christopher.
The problem is you've got senators with a capital S and lowercase after that.
Right. So I'm taking the value they type in for a hockey team, converting it to all uppercase letters, and saying, by the way, is senators all uppercase, is the value they typed in all uppercase equal to this value that contains lowercase letters? And that's where I sort of sit there and go, oh my God, did I really just do that?
Yeah, you've hard-coded in a bug.
Yeah, so what I should really do here is this should be senators would be helpful. And now it should match, no matter how I type it in. Yay, success. Where I usually actually get caught with this isn't necessarily that I had the string senators. What often happened is somewhere earlier in my code, you know, earlier in the day, I had written some other
Meanwhile, up
code
the
early.
ranch.
Exactly. I had written a best team, type that, best team equals senators. And what I had was maybe I had something like it was up here somewhere else, and over here I said, oh, if favorite team equals best team, then go ahead and continue. And maybe this was even a value I read from a file somewhere where I couldn't even control the case. So maybe when I read this from a database or read this from a file, I don't know if what I read from the file was uppercase or lowercase. So I'm saying compare what they typed in to a value I read out of a database or out of a file. So now I'm saying, well, I want to convert it to uppercase so it's case insensitive, but now what I need to do is go back to the code, and I may need to actually say convert both sides to uppercase before comparing.
And that generally is the best way to approach this, that if you're going to say, I'm going to convert one side to be it uppercase, lowercase, or otherwise, convert the other side as well, so that way you know that it's always going to be that consistent casing, so you won't get stuck there. I would also mention that a couple of people mentioned about, well, you could use capital, you could use lower, and all of that is 100%
They will all work.
true.
They will all work.
Yeah, as long as you call the same function on both sides, make sure that they're both cased the same way, it'll work.
Yeah. For some reason, upper seems to be the more popular choice.
Yeah.
But there's absolutely, it would work with lower. It would work with the initial capitalization function as well. Yeah, just make sure they're both the same casing. It does happen. That is one of Susan's pet mistakes that I just make all the time. So I just wanted to share that one with you. One of the other things that's interesting about writing if statements, we learned about how you can write code different ways. If statements can often be expressed in different ways. If you look at this slide, I could say, if the answer equals yes, do the following, or I could say, if the answer is not equal to no. So the syntax for saying if the answer is not equal to no, I could have used the exclamation mark equal symbol, or I could have said if not answer equals no. This is a way of saying if the condition I'm providing is not happening, if this is not true, do this. So saying if the answer is yes, do the following. If the answer is not no, do the following. It's kind of saying the same thing. I could say if the total is less than 100, or if not, total greater than or equal to 100. Because if a total is not greater than or equal to 100, then it must be less than 100. So which is the right way to do it? Well, I don't know. It really falls into a certain amount of what do you like. I find it easier to express it in a positive way. I find saying if not total, if not answer kind of confusing. My brain just, especially, hey, when I'm getting tired and it's late in the night, I start looking at that and my brain has to think about it 6 times.
Exactly. Yeah, and especially if you've got, the word not, and then you've got not equals there, and now you're dealing with, double negatives and double secret probation, and, I just don't want to have to sit down and try to figure all of that out. So really, when it comes to writing those things out, keep it as simple as possible.
But
what's the easiest way you can state it, and just go with that.
So generally I will try to put things in the positive perspective rather than the nots if I have a choice. But the other way I think of it is, think of it how you would say it out loud. If a course is completed, then send a certificate to the student. So you'd say, well, an if course completed is yes, send the certificate. If the order is under $50, add a shipping charge. Okay, then if total is under 50, add shipping. If a cat has not been vaccinated, call the owner. Now this one, you go, oh, see, now this one, it's if they have not been vaccinated, call them over. So in that case, I might actually use if not vaccinated, because it's actually the way I think of it. I only do the action if the cat is not vaccinated. So,
You could also use the not equal, so you could say if vaccinated, bang equal, or bang, exclamation point, bang, it's a Unix thing. In any event, you could also say the exclamation equals. And again, it does come down to a matter of personal preference.
Absolutely.
Which do you think is going to be the easiest to read?
And by the way, that is a great way that's another great geek tip. You want to learn how to speak geek with your geek friends? They'll say bang for exclamation mark. It's just one of those terms that's used. And yes, it's a hangover from... hangover, that's a nice term. It's held over from the days of Unix. Maybe it is a hangover from Unix. Let me tell you. There was some stuff going. Unix was not a user-friendly place to be coding. Bring back the VI editor, no.
It makes sense.
And we did talk a little bit, this is just reinforcing that it is case sensitive when you do a comparison. So if you type uppercase and your if statement is looking for lowercase letters, then it's not going to be considered true. Uppercase YES is not equal to lowercase YES. So it becomes very important to use a function like lower or upper, and do a conversion before you do the comparison. And you may want to actually convert both sides, especially if you've got a variable on the other side. You might want to do that convert to lowercase on both sides of your expression. Now, what if we want to do an if statement that uses numbers instead of strings? All the examples so far have been looking at strings, but absolutely there'll be times you want to do things like, hey, when you deposit money, if you deposit over $100, you get a free toaster. I remember these days.
Yeah, I was just going to say, yeah, you can't be 29 and remember the days of depositing something and getting a free toaster.
Hey, are you kidding? People still use toasters? What's wrong with that?
Well, yeah, but you don't go to a bank and get a free toaster anymore.
Where do I go get a free toaster?
We give them out here.
We give them out here.
All right.
All right,
okay,
cool.
free toasters.
Yeah, so we'll go collect a toaster. Excellent.
Awesome. So in this case, if you follow the sort of logic, if a user enters a deposit amount of 150, then that's more than 100, so you get a free toaster, and it'll say have a nice day. If they enter $50, well, $50 is not more than 100, so they will not see the message you get a free toaster, they'll just see have a nice day. But here's the big one. What happens if they specify exactly $100? What do you think there?
So if they specify exactly 100, so it's got to be greater than, it wasn't greater than, so it's just going to be have a nice day.
Yeah.
You're not going to get a free toaster.
That's right.
There's no toaster love.
No toaster love. That's right. 100 is not greater than 100. It's equal to.
Right.
And this is one of those scenarios where it's really important when you're working with if statements and numeric values to test all those combinations. Test a greater value, a lesser value, and exactly equal to. And then if you're not sure, because you really have to ask, and sometimes you may have to go ask somebody, hey, if it's exactly $100, not $100.01, $100.01 is greater than 100. But if it's exactly 100, do they get the free toaster? Because those kind of mistakes can actually cause some pretty serious problems.
Yep.
Because you're actually changing their business rules if you don't do it correctly. So I think we can do a quick example of using some numeric values. So this is if statements with strings. And I'm going to use your wonderful trick you showed us earlier, Christopher. I'm going to use that Control-K-C command.
Control-K, Control-C.
Well, you just hold down the Control key. You
Well,
go
yeah.
Control-K-C.
Yep.
I just hold Control, go and Control-K-C.
Yeah, I always just say it with the second control, because a lot of times people let up off the control.
Yeah, you have to hold the Control key down the whole time.
Exactly.
Very true.
Yep. Yeah.
But I love that little keyboard shortcut. There's a way of adding that to your toolbar as well, but I can't remember how to do that.
Yep.
So let's add an if statement here, if with numbers, and we're just going to say if, let's see, let's do a deposit equals an input of how much do you want to deposit. There we go. I'm going to add another space there so it looks a little bit nicer on the screen. And then I'm going to say if deposit is greater than 100, then we are going to print enjoy your toaster. Woohoo! All right.
Toast.
Yes, exactly. And otherwise, we're always going to say print have a nice day, because regardless of how much money they deposit, we're going to always wish them to have a happy day. All right, now the first thing is when I run this code, I'm going to run into a little bit of a crash. I am expecting this one. Deposit, I want to deposit $150.
See, we'll always admit when we had something go sideways that we weren't expecting.
Yeah.
This one we were expecting.
This one we are expecting. And I love, I do love the fact it gives me even a line saying, this line here blew up on you, Susan. It says, okay, you have an error. What is that error? Well, that error is unorderable type string greater int. So we're back to the usual problem again, that we have a string value and it's trying to see if a string is greater than an integer value. So we can't compare a string and an integer. This is like when we're trying to add strings and integers or compare them one equal to another. So it's my data type problem coming back to haunt me again. Because if we go back and look at our code, you can see that we used the input function to ask somebody to enter a value, and input functions return a string. And then we're trying to compare a string to the value 100, so it's giving me an error.
So there we are back at data type conversions here.
Right, so we have to think back 2 modules now. And it's funny how we were like, man, 5 modules in, I got to go back 2 modules. This is getting hard on the brain. But there was that float function, and I'm going to get fancy here. I'm
Ooh.
actually going to do it. This was actually suggested by somebody in the Q&A.
Yeah, a lot of people
saying, why don't you just convert it to a float right away when you get it back?
And the answer really is, it just depends on your level of comfort. That I know a lot of people that will look at that, especially people that are new to programming, and seeing the two things happen at the same time will kind of cause them to be thrown for a loop.
Yeah.
So they like that separate breakdown of just take the user input first, convert it second. Okay, now let's go ahead and use it. But can you go ahead, just like Susan had on her code here, and combine them both? Absolutely, 100%.
Yeah.
Yep.
So it's just said, you guys have some choices there in terms of how you write your code.
Yep.
Somebody had asked about it in the Q&A, so I just wanted to show you, absolutely, if you want, you can take the value returned by the input and immediately convert it to an integer or a float before you put it in your variable. So right away, it's treated like a numeric variable. So if we go back to the code, you can see I have basically said take the results of the input statement and convert it to a float, which meant I did need to remember 2 closing brackets at the end. One to close the input command and one to close the float.
Paren, paren.
So now when I run, and this time when I type in $150, oh, now it's blown up for a different reason. Unorderable types. It's still giving me a string. Did I get something?
You want it to be an integer, I believe.
Oh, integer?
Just 100.
Oh, yes. It's an int, not a float. Thank you.
Yep. Data types.
Yes, it's all getting the right data types. 150. There we go.
There we
Enjoy
go.
my toaster. Yay!
Yay,
I get to have a
yay
nice
toasters.
I get my toaster. This is all good. So again, now, but of course, remember, I just want to prove that if I type in exactly 100, I
Just
don't get a
go
toaster.
have a nice day. Yep.
100 is not greater than 100.
Yep.
Which hopefully is the way the bank wanted me to implement it. I'd better go double check if I'm not sure. That is so important. When in doubt, ask your users. Find out the real business rules. So, yeah.
I was just going to say, now we've actually got enough skills that we could, take the rounded pennies off and start funneling them off to a separate account somewhere.
So it seems to me somebody did that many years ago and made rather a scary amount of money and got in a lot of trouble later.
There should be a movie around that as well.
Yeah.
In any event. Okay, carrying on.
Going back,
Yes.
so just always remember when you're testing, if we look at the slide, we always want to make sure when we're using greater than and less than in our if statements, when you're testing, always test a value greater than, a value less than, and what we call a boundary condition, the exact value you're comparing to. Always test all 3 situations. Now, one of the things we did just talk about was the issue of when we're asking people to enter a value, right? We use an input statement. You can run into data type conversion errors just like we did now. And so you may need to actually convert that to an integer, because you can see below that if I actually take a look here, you can see in the error message that the actual error message that's being returned is it's got an integer on one side, a string on the other. So we need to convert that we need to convert the string into an integer so we have the same data type on both sides. So we fix that. And you know what? My apologies if there's a typo on this slide. That should be if int deposit, not if float deposit, because we just saw that in the demo, but when I convert it to a float, it doesn't work. Now here, you'll notice I actually converted the data type when I did the comparison. So it's funny, every time I write the code, I approach it a different way. I don't always think about it. So lots of different ways that you can, there's different times in your code when you can do the conversion. It's really up to you. Do you want to do it right away? Do you do it when you need it? The only thing I would say is if you're going to find yourself converting it 8 or 10 different times, do it once, put it in a different variable that'll store the float version of it, or do it right away. Yeah. Because I'm lazy. I don't want to have to convert more often than I have to.
I'm noticing that theme today.
Yeah, I'm lazy with my code.
Yeah.
And here's the example actually where I've done the conversion when I actually use the input statement. So I do have that example in the slides as well. Though again, I'd like to make a point. I did make a typing mistake here. That should be int input, not float. So replace float with int, please. I will try and fix that in the slides up on the GitHub when we have a break. All right. So the other thing that you do run into is, what if they don't get a free toaster? You might say, well, you get a free coffee mug no matter what, but if you deposit over $100, you get a free toaster. So we run into these situations where you get one or the other. So if you get this, if you deposit over $100, you get a toaster. Otherwise, you get a coffee mug. And in coding terms, that's else. So there is a special syntax we use. You use the keyword else, and you have to remember that colon after it. And this code will only be executed if the condition is not true. So in this case situation, If they have over $100, it will execute and give them a free toaster. If it is not over $100, if that statement is not true, then it jumps down and runs the code in the else statement. And it's important that the code inside the else statement is also indented so it knows what is the code to execute when the condition is not true. So now I have a one or the other type situation. It will either give me a free toaster or give me a free mug, but I'm getting something either way, no matter what I deposit now.
Yep.
So the else statement is only executed if the condition is not true. If we enter $50 in this scenario, Christopher, what's going to appear on the screen if I put in a deposit of $50?
Enjoy your mug. Have a nice day.
All right. What if I enter $150?
You get a free toaster. Have a nice day.
And if I specify exactly $100?
Enjoy your mug. Have a nice day.
That's right, because $100 is not greater than. We always want to test that boundary condition.
Yep.
Another neat trick, and I'll do a demo of this one in a second, is the idea of Boolean variables. So there wasn't one variable type we didn't talk about earlier, and that is Booleans. So a Boolean variable allows you to actually remember the result of a condition. So in this case, I've got code that goes off and asks the person how much they want to deposit. And if they deposit more than $100, then I actually create, and we often call these variables flags. It's just a naming convention we often use for Boolean variables that store a true or false, because they're often flags to us. Has something happened or not happened? So we'll often use this term and call these Boolean variables flags. So I'm creating a flag here, but in the end, it's just a variable, and the variable stores a value of true or false. And I'm saying if they deposit over $100, free toaster is true, because, yeah, they can get a free toaster. And then later in my code, maybe I have a whole bunch of other complicated logic that actually updates their balances and so on in the actual system. And then later I say, oh, by the way, I got to remember, by the way, if free toaster is true, but you don't have to say if free toaster equal true.
Right.
You can just say if free toaster, then do the following.
And then the advantage here is your code is more readable. So if you put in that $100 value or something like that, the problem is, number one, if you're using that in multiple locations, you have to go in and kind of keep stressing that. But also number two is that you've now given a little bit of meaning. So kind of going back to our comments, and that can oftentimes be used to try and disguise bad code. Now, if we go in and we say free toaster, well, when I go in and I look at this, I know exactly what we're testing. I'm testing, do they get a free toaster? Rather than having to interpret, okay, well, what was the amount supposed to be? You know, and that way I could put that somewhere else, put that, say, in a function. We'll talk about that tomorrow. Put that up earlier in the code, and then in the long run, my code can be more readable and also more maintainable, because that way, if I'm doing that test multiple times, the rules change. I only have to update one spot of code.
And that's it. Yep. All about being lazy. You know, it's funny, writing the code, when you start getting further into coding, one of the things you'll discover is one of the constants of life is change.
Yep.
And whatever the business rules are now will change.
Yep.
Right now, it's $100 gets you a free toaster. Oh, guess what? Inflation, you now have to deposit over $1,000 to get a free toaster. So if I had 3 or 4 different parts of my code, maybe there was a part of my code that says, if they deposit over $100, send an email to the person to order the free toaster. And if they later on you have, oh, by the way, if they deposit over $100, we need to prompt them for the shipping information so we can send them the free toaster. And we also have to make sure that somewhere in the code we have this logic that says, if they deposit over $1,000, then, you know, enough to get the free toaster, then we have to remember to send them an email saying, hey, congratulations, you're getting a free toaster.
Right.
So, like 3 different things we have to do, and maybe our code is kind of chunky, so it's all not nicely tidy and put together. And then, yeah, down the road, they change their mind about the amount. And what happens, and this has happened to so many coders, you remember to update it in 2 of the 3 places. And then suddenly somebody's going, how come we ordered this person a free toaster, but we never asked them for their shipping address? And you're like, but that was working before. And then you realize, oh, I set that rule, and I was checking it, and I forgot to update the threshold amount of what we get from a free toaster in this place, but I updated it the other 2 places.
Yep.
By using a flag, we check the condition once, set a flag, and then we just use that flag anywhere else we need to check, did that happen? Do they get the free toaster? If so, ask them for the shipping information. Did they get the free toaster? Order of a toaster. Did they get the free toaster? Send them an email and say congratulations. So yeah, it reduces the chances of you making mistakes later.
Yep.
And those are nasty mistakes to catch. because your code works, and it might be a month before somebody clues in that one little, that you only fixed 2 of 3 places.
Yep.
So coding once is not only lazy coding, it can also be safer coding.
You know, I will always remember I was talking with somebody who had gone in, and this is a long time ago, but he had set up, I was at a training center, he'd set up all of our different routers for all of our different classrooms, so that it really was that you could just walk in, unplug one of these things, drop it into any other classroom, plug it back in, and make one change, just like go in and update the name of the computer, give it a reboot, and poof, it automatically started working. And I just looked at the amount of work that he had to do to make all of this happen, and I looked at him and said, why in the world did you go through all of this effort? And he said, because I was too lazy to not do it right the first time. So, you know, when we talk about lazy, we're not really just talking about...
We're not being disparaging.
Exactly. We're not being disparaging. We're not talking about just throwing slop together. That we are talking about, you know, if you make a good code up front, in the long run, that's going to make your life that much easier.
It's actually efficiency.
Exactly, yeah. Be lazy. Be lazy. Because when you're thinking about, well, if I have to go back and update this later on, which you will, the only constant in software development is change. If you only have to update one spot, that's going to make your life easier. And that's also going to, in turn, feed your laziness. So keep that in mind as you're going through and writing your code. What's going to be the easiest to maintain? That's the lazy code.
Yes, it's said. So we use the word lazy. We're kind of joking. What we really mean is it's efficiency. Efficiency in our effort, both in creating the code and in maintaining the code later. Because I don't know if you realize that probably when you get into coding jobs, probably 20% of the coding you do is creating new code, and maybe 80% of the code you do is maintaining and updating existing code.
And if
that's
not, maybe
the real
a
world.
90-10. Yeah, exactly. Somebody just mentioned right here, lazy perfectionism. That's a phrase that I really like. So, yeah, Scott, I'm stealing that one. Thank you, Scott. Lazy perfectionism.
I love it.
I like it.
All right. So these things like a Boolean variable are really useful for that sort of situation.
Yep.
But of course, if you're using a Boolean variable, whenever you're testing if statements, make sure you test what happens if it's true, what happens if it's false. Always test both conditions, because you may find the code works once and not the other way. In fact, I'm actually going to do that exact example. Where I'm going to say, if a deposit's greater than 100, then I'm going to set a flag called free toaster equals to true. So I'm creating, that reference I got, but it was pretty obscure. So I don't know how many people know enough Eddie Izzard to get that reference. So if a deposit's over 100, I'm going to set free toaster as true. And then I'm going to imagine I have a whole bunch of complex code here. And then later in my code, oops, don't need a double, I say if free toaster, then print enjoy your toaster. All right, so if we take a look at our code now, so just scroll down a little bit. So we ask them to enter how much they want to deposit. If they deposit over 100, we set our flag free toaster to true. By the way, this is case sensitive. Lowercase t for true is not right. Uppercase is correct. The color coding can help. If you don't see the blue, that means it's not recognizing it as a keyword. And then we say if free toaster, and you can imply here is equal to true, but you don't have to say. You can put it there if it helps you. You can say equal true. If that helps you to remember. No, uppercase.
Oh, sorry. You're right. Sorry.
No problem.
My brain just immediately went to C# there.
No.
So,
I know. I always get that one in Python. So if you prefer, if it makes more sense to you to type if free toaster equal true, by all means do it. It's unnecessary though. Then enjoy your toaster. So now I've got this code. I execute, and I say I want to deposit $500. I always test greater value. It says enjoy your toaster. Have a nice day. And then I'm going to be a good tester. I'm also going to test a smaller value, and then I'm going to test the boundary value, $50.
And while you're doing that, this is perfect, because somebody just asked in the window, would it not be a good idea to default free toaster to false above the if? It was like, we
like
knew
you knew.
Yeah.
Excellent question, because look what happens when I specify $50. Boom, it crashes. Because what happens here, if you take a look, it says free toaster is not defined. It can't find the variable free toaster.
Yep.
You go, wait a second, I declared it there, but then when you stop and think about it, you realize I only create the variable free toaster if they deposited over $100. So it doesn't have a value, it doesn't exist. So when you just say, hey, look at the value of the free toaster, it goes, what value? What free toaster? I've never seen it. So this is where good habits, it's a good habit to declare your variables and give them an initial value at the top of your code.
Yep.
So I'm going to say, assume by default that free toaster is false. And then if they happen to deposit over $100, then change that to true.
Yep.
And that's going to get rid of that nasty error message.
Don't forget to hit stop.
Oh, yeah, thank you. My code is still running, so I need to stop
There we
it
go.
and run again. And now, if I specify $50, it says, oh, that's nice. Have
Yep.
a nice day. Just to be thorough, though, I'm going to be a good tester. I'm going to test my boundary condition. $100 should not give me a free toaster. Excellent. I have coded my lines correctly.
Well done.
So initializing variables, especially Boolean variables, very good habit, because otherwise, and that's why it's also very important to test true and false, greater than, less than, equal to. Test every possible path, because you might have gone and said, hey, it's working.
Yep.
And then one day somebody deposits less than $100 and the code crashes.
Yep.
Yeah, so we want to make sure we do lots of good testing. All right, we've just done that. And we just walked through this exact scenario of why did it crash? Because the variable was only declared if the values were greater than 100. So we had to initialize the variable. So this is just the same code. I'm going through it quickly because we just saw it in the demo.
Yep.
Are we just making the code more complicated by using the Boolean? Again, we just had that whole discussion. You know, there might be more than one place you have to check the conditions, so we're trying to be effective and efficient. If it's very complicated, it can make the code easier to follow if you just write the logic for checking it in one place, and then you just check the result later on when you need to. And we often call that a flag. So we had that whole discussion just a couple of minutes ago. But now we have more ways to make some typing mistakes. So Christopher, I'm going to challenge you. See if you can find 3 typing mistakes here.
Deposit equals, if float deposit, it should be int, but.
Yes, it should be int deposit. Yeah, okay, bonus. There might be 4 mistakes because we were just seeing that
actually,
should be int.
you know, one of the things, and somebody pointed this out in the chat window, for whatever it's worth, you actually didn't make a mistake. Float does work.
Okay.
The reason that it failed was because you still had the code running.
Oh.
See, so you didn't make a mistake after all.
There you go.
So you can take that off your quota for the day.
Well, that's good, because now I don't feel so bad, because I was thinking, did I make the mistake on all the slides? I was like, okay, I feel better now. So
exactly.
I had something else wrong with the code. Okay.
Yep. So anyway, so to bring the slide back up, so free toaster.
So I'm going to remove that because that's okay.
Yep.
Yep.
True should be uppercase T.
Correct. Excellent catch. That's a sneaky one. You know, that's a, oops. Oh, I cheated and gave you a hint. Hey, hang on, I got to take those away. I gave you a hint. All right, hang on. Yes, that should be uppercase T. Absolutely.
The second problem is you need a colon after 100.
I forgot my colon here. That is correct. After the if statement.
Third problem is free toaster needs to be tabbed in.
Yes, this needs to be indented. That is correct, and that's,
yep.
You've got it.
All right, go me.
So there we go. So those are the mistakes we had. We forgot the colon in the if statement. We forgot to indent the line about setting the free toaster flag to true, and we forgot true. We accidentally entered uppercase. So your challenge, now that you've seen all this, you're going to try and calculate the shipping charges for somebody making a purchase. You're going to ask the user to enter the amount for their total purchase. If it's under $50, add $10. Otherwise, shipping is free. Tell the user their final total, including shipping costs. And here's an extra little credit challenge, because we haven't covered it. So this is going to require going off and doing a little Bing search to figure it out. Format the number so it looks like a monetary value. Add that dollar symbol to the output.
There you go.
I'm not going to challenge those of you working in other locales to start including euro symbols and so on. Just doing the dollar value will be a little challenge for you. Let's not get into localization just yet. And don't forget to test your solution when you're done with the value of 50, less than 50, and exactly 50.
There it is.
So congratulations. You can now write code that reacts to different conditions and solve problems that require decision making.
Cool. Well, yeah, I think there's still one more module left to cover today that we want to go in and kind of take a look at a bit more complex if statement, things like ands and ors and all that good stuff. So what do you say we take 10 minutes? I could use a bit more water, and then we'll come on back and we'll close today off. Now remember, we still have tomorrow, so still an entire day tomorrow.
We're going to draw stuff tomorrow.
Yeah, we've got a lot of cool stuff tomorrow. But for right now, let's go ahead and take 10. We'll see you guys back here to finish off the last module of today. So 10 minutes, we'll be back here.